Hello, this is Mr. Stansbury. I'm going to take you through the second half of the notes for solve linear quadratic systems. At the end of this, you should be able to say I can use different methods to solve and graph nonlinear systems, and I can describe solutions to nonlinear systems. Okay, so let's take a look here. We're going to first solve the system by graphing, and we got y equals x minus 8 and y equals x squared minus 4x minus 2. So graphing the linear part, not too bad. Graphing the quadratic, a couple ways to do it. We're going to do it by completing the square, because we just have recently done completing the square. So we're just going to go ahead and go through and solve this by, we're going to put it into vertex form by completing the square. Okay, so first thing we're going to do is we're going to move the constant to the other side. So we're going to add 2 to both sides. So we get y plus 2 equals x squared minus 4x. And then we're going to take half this middle term, right? So we take negative 4 divided by 2, and we get negative 2. That negative 2 I'm going to circle because we're going to need that coming back here in the end. But we're going to take that negative 2 now, and we're going to square it, and that gives us 4. So we're going to add 4 to both sides. So we're going to have y plus 2 plus 4, and then we're going to have x squared minus 4x plus 4. Oops, not plus or minus 4, but just plus 4. Okay, so we added 4 to both sides. So now over here on the right side, we're going to rewrite this as a perfect square. And the reason why I always circle this thing here is that is going to be a big part of our perfect square. So it's going to be x, and whatever this is right here, x minus 2 squared. And then over on this side, we've got y plus 6. And then our last step to put it back in vertex form is to now move this 6 back to the other side. And so we get y equals x minus 2 squared minus 6. So there's our vertex form. Okay, so we're going to use this little table thing over here. We're just going to do 0 through 3 because since it's a parabola, we know it's going to be a mirror image. It's going to reflect right through the vertex. We'll show you that here in a second. But so if we have x is 0, we're going to do 0, 1, 2, and 3. So if we square that 0, we get 0. 1 squared is 1, 2 squared is 4, 3 squared is 9. So these are like the general easy ways just to like graph a regular parabola. So there's 0, 0, 1, 1, 2 is at 2 squared is 4, 3 squared is at 9. So here's our parabola, and if you remember, it's going to reflect right along the x-axis, well, right down the vertex in this case. Sorry, always the vertex, but which happens to be the x-axis. That's what I was trying to spit out. And so we end up, there's our original. This is plain old y equals x squared, but we don't want that. We want to do it with this one here, right? So we know that this x minus 2, I always think of, it's like, what do I put in for x to make this equal 0? 2 minus 2 gives us 0. So we're actually adding 2 to all the x's. And then the y, we're shifting everything down 6, so we're going to subtract 6 from all the y's. And there's nothing to multiply there's nothing out here to multiply the x's by, so that's just going to be 1x, right? So all the x's, we're going to add 2 to it. So it's 0 plus 2. And then the y on this case is going to be 0 minus 6. So the vertex, according to this formula here, is going to be 2, negative 6, which we know is true because there's our 2 and there's our negative 6. And we can do the same for all of these things here, right? So we're just going to take all the x's and add 2 to it. So we got 1, 2, and 3 for the x's, and then we're going to have 1, 4, and 9 for the x's. Then we're going to add 2 to all these x's, and we're going to subtract 6 from all the y's, right? And that will give us some points that we can graph, and then we'll be able to reflect that line, reflect the get the other half of the parabola by reflecting it over the vertex. All right, so let's see, that's 3 and negative 5. That's 4 and negative 2, and that's 5 and 3. All right, so let's graph these things here. I'm going to get rid of, see if I can get rid of that. I can't, so we'll just graph these here all in pink. All right, so we've got our vertex at 2, -6, and then we're at 3, -5, 4, -2, and 5 and 3, which is right there. And then again, here's our vertex, so we can make a little line here. Let's make that with a different color here. Let's do yellow. So we're going to make ourselves a little dotted line here that goes right vertically through the vertex. And then we know that we can reflect all these points across that line. So that's going to go over here. This is distance of 2, so we go 2 more to reflect it straight across there. That's a distance of 3, so go 1, 2, 3 more. And then here's our parabola. Forgive that, that's a pretty horrible parabola. I'm going to try that again. Not a lot better, but at least it's a little bit better. Okay, so there's our parabola there, and then now let's go through, and then we're just going to graph this y equals x minus 8. So we're going to start at -8, our y-intercept, right? And then our slope is up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1 right there. So we've got this here, and we can make ourselves our nice straight line with these. All right, I've got my little cheater ruler here, but there we go. So we get that right there. We can tell right from our graph we have 2 points right here and right here where they intersect, and that's going to be, so our 2 solutions are going to be at, what is that? That's our vertex at 2, -6, and we also have got another one at, let's see, 1, 2, 3, -5. So those are our 2 solutions for this system. Okay? Okay, we got the second and last example to do, but before we do that, we'll take a quick little comedy break.
Forbid I go to a store she has a coupon for. I mean, I'll be walking in the parking lot, just get a call, don't buy anything, I have a coupon. I'm like, do you think I'm going to come home and get that coupon? Is that what you think's about to happen? I'm going to try to pay more now that you called. I don't even know if Target allows that, but I'm going to try to negotiate up on this toothpaste. You better hope they don't ask me to round up. I'm rounding up. I hate coupons so much, and she's addicted to them. She will not let me leave. Like, I got a coupon. I'm like, I just feel so stupid. I'm buying deodorant, and I'm like, I don't have all the money, but I'm almost there. But I do have this coupon. One day, I hope to be able to pay full price. We are saving up as much as we can.
All right. Last one here. The height h of a cactus cone in meters at t seconds after it's thrown from a platform is modeled by h equals -5t plus 10t, 5t squared plus 10t plus 15. At the same time the cone is thrown, someone throws a snail at the cactus cone. The trajectory of the snail is given by the equation h equals 3t plus 3. Will the paintball, not the paintball, but the snail, that's what it says. Will the snail hit the cactus cone? If so, when and at what height will the cactus cone be? Okay, so we've got our equation here. We've got h equals -5t squared plus 10t plus 15. So if we're gonna put this into vertex form by completing the square. So first thing, subtract 15 from both sides. H minus 15 equals -5t squared plus 10t. Now, we got to get this -5 out of there, so good thing that both of these are divisible by 5, so we're going to factor that out. H minus 15 equals -5 times, and we divide this by -5, and we're just left with t squared. Take 10 and divide it by -5, we get -2t. Okay? Now, with this, now we can go through and complete the square. So we're going to take half of the t term. So that's -2 divided by 2 is -1. Right? Circle that because we're going to use that later. -1 squared is 1. So we're going to add 1 to both sides, kind of. And by what I mean with that, h minus 15, I'm going to leave a little blank there because we're going to add something over there. We got -5 times t squared minus 2t. And we want a plus 1 here, right? But look, this +1 is actually being multiplied by -5. So we're not really adding 1 to this side. We're really adding 1 times -5. So it's really subtract 5 here. So to make up for that, we have to subtract 5 over here as well. So these two, now we've balanced both sides. So we get h minus 20 equals -5 times t, right there. That's why we circle that and use it later. T minus 1 squared, right? And then we're going to add the 20 to both sides to finish it off, and we get h equals -5 times t minus 1 squared plus 20. There's our vertex form. Okay, so with this here, we're adding adding 20 to all the y's, right? Because we're shifting it up 20, and we're moving this t to make this parentheses here equal to 0. This t has to be +1, so we're going to add 1 to all the x's. Okay. Now this -5, we're gonna end up multiplying all this in here by -5. So that's actually not going to affect the x, but it is going to affect the h, the height. So that's getting multiplied by -5. So what we're going to want to do is take that -5 and put it right here. So -5 times y plus the 20. So if we do 0 plus 1, and then we're going to do -5 times, not 50, -5 times 0 plus 20, and then all of these are going to be +1, and then -5 times whatever number we're at plus 20, okay, for all of those. So we're going to put the x's in here, 1, 2, and 3, and then the x squareds or the y's in here, so that's going to be 1, 4, and 9. Okay, so on this here, we're going to end up getting 1, and then -5 times 0 is 0. So we get 1 and 20 as 1 point. And then we do this one here, and that's going to be at 2. And -5 times 1 is -5 plus 20 is 15. And then that's going to be 3. -5 times 4 is -20 plus 20 is 0. And then on this one here, we get 4. And then -5 times 9 is -45 plus 20 is -25. We'll talk about that one here. So now we can plot these points here. We got 1 and 20 right here. That's our vertex. And then we've got 2 and 15. So that's right here. 3 and 0. And 4 and -25 is going to be way down off the screen here. That means at 4 seconds, the ball height would be -25 meters, which obviously does not make sense. So we'll get rid of that one. Okay, and then we can, let's see, this is our reflection line right here. So we know that it starts right over here at 15, which we know is true because there's our starting height of 15. Okay, so if we kind of sketch this graph here, and we kind of get a graph that looks something close to that. Again, not beautiful, but you get the idea. Okay, so then now let's graph this equation here. H equals 3t plus 3. So we're going to start at 3, and then we're going to go 3t, so up 1, 2, 3 over 1, up 1, 2, 3 over 1, 1, 2, 3 over 1, so forth and so on. And then we can draw ourselves a nice straight line through all of those. At least I can, because I get to cheat with my program here. And it looks like it intersects right in, let's do that with a different color. Looks like it intersects right in here, doesn't it? Right at about somewhere between like 10 and 11 feet up. Okay. So, will the snail hit the cactus cone? Yes. If so, when? Looks like somewhere between 2 and 3 seconds. Okay, and then at what height will the cactus cone be? It'll be at about between 10 and 11 feet, roughly. Okay? All right, that's all we have for the second half of these Solve Linear Quadratic System notes. If you have any further questions, please feel free to ask in class. Thanks.